Hello students, welcome back to GradeBooster. Today our lesson is electricity from class 10 physics. So in this lesson we are going to learn the basic concepts of electricity, electric current and circuit, and electric potential, potential difference, electric power and all these things. So let us begin with electricity. What is electricity? Electricity is the flow of electric charges. Flow of electric charges in a conductor is called as electricity. We can also say that electricity is the flow of electrons. Both are same. Electricity is the flow of electrons or is the flow of electric charges. That is called as electricity. Okay. Why do we need electricity? We need electricity for lighting, heating, cooling, running machines. For all these purpose we need electricity. Right? So even now vehicles are being run by electricity, electric vehicles, electric cars and electric bikes. So electricity is very important and inevitable part of our life. Without electricity, I cannot make this video. You cannot see the screen, right? So for everything we need electricity. Most of the tasks are done by electricity. Now let us understand what is electric current and circuit. So what is electric current? The rate of flow of electric charge is electric current. The rate of flow, right? Say for example, you have taken a pipe, some 1 meter pipe. So in this 1 meter pipe, some water is flowing. If you would like to calculate how much water is flowing in this 1 meter pipe per 1 minute, that is the rate of flow of water. So you would like to calculate how much water is passing through this pipe, 1 meter pipe for 1 minute. That is the rate of flow of water. In the same way, if we try to measure the rate of flow of electric charges flowing in a conductor, that is called as electric current. That is called as electric current. How do we calculate electric current? I is equal to Q by T. I, electric current, is equal to Q. Q means the amount of charge and time. Amount of charge by amount of charge by time. By this we can calculate the electric current. What is the SI unit of electric current? Ampere. So what is the direction of electric flow? Electric charges, the flow of electric charges is called as electricity. But from which direction to which direction they flow? Positive to negative or negative to positive. So conventional flow of electricity is positive terminal to negative terminal. That is the conventional or traditional way of showing the flow of electrons, positive to negative. Okay, right. So from positive to negative, it is the conventional way of showing the direction of current, current flow from positive to negative. But in fact, electrons flow from negative terminal to positive. That's a different thing. But conventionally, traditionally, how we have come to understand this concept right from the beginning, okay, positive to negative terminal. So that is conventional. Now electric circuit. What is electric circuit? Electricity flows in a conductor, but this conductor, it should be in the form of a circuit. See, for example, here is a wire. Here is a wire. Okay. So I kept one cell, one battery here like this. Here I kept one bulb. Will the electricity flow now? Here is a conductor. Will it flow from battery to bulb? Will the bulb glow? No. The conductor and the components, everything should be in a closed circuit. Only then the electricity passes. That means here, from here I should take another terminal and connect it like this. Now the bulb glows. Now this is a closed circuit. When a circuit is closed, then the electricity passes and the components, they work. And if you break the circuit, no electricity passes, right? So whatever the lighting, fans, everything we have in our home, they're all a part of a circuit. Okay. So before making a circuit, they will draw the diagram of an electric circuit diagrams. So in these diagrams, they use some symbols for convenience. To show some bulb, one symbol is used. To show some resistor, some symbol is used. Here are the symbols. You can look at the symbols in this picture. This is the symbol to show a cell. Okay, cell means single battery. This is battery, that means more than one cell. This is the connecting wire. This is a wire joint. This is a wire crossing without contact. So like this one wire, like this one wire. These two wires are not contacted. So it is shown like this. This is the resistance, variable resistance, ammeter, voltmeter, and open switch, closed switch, electric bulb, galvanometer. Like this, while drawing a circuit, we can use different symbols to represent the components. The symbolic circuit diagrams use standard symbols for components. That is about the electric circuit and electric current. Okay, next, let us move to the next topic. Electric potential and potential difference. What is electric potential? Work done to move a unit charge, that is electric potential. What is electric potential? Work done to move a unit charge, that is electric potential. That means I have a ball in my hand, and I would like to take this ball from here to here and place it here. I have the ball in my hand at this position. From this point, I would like to take the ball to this point and place it here. Now, so I placed the ball over there. So that is the work done to place this ball from this point to that point. In the same way, electric potential means to move a charge from one point to another point. How much work is done? That is the electric potential. Okay. So that is the electric potential. So work done to move a unit charge from infinity to a point. Infinity. We have not specified from where it is moving. Infinity to a point. Okay. That is electric potential. Now what is potential difference? What is potential difference? Work done to move a coulomb of charge from one point to another point in a electrical field or in a circuit. In a circuit, there are 2 points. Okay. In a circuit, there are 2 points. So what is this potential difference? Work done to move 1 coulomb of charge. This is 1 coulomb of charge from one point to another point, So to move this charge from this point to this point, how much charge? It's a fixed charge, 1 coulomb of charge from this point to this point in a circuit or in an electrical field. So that is called as potential difference. Okay, right. So you take one water tank and there is another water tank at the low level. The water flow from higher level to lower level. So when there is potential difference in a circuit, the current flows. Why the current flows? Because there is always potential difference is maintained. Once the potential difference is maintained, the circuit flows. In the same way, you take one big tank, one tank at the lower level, one water tank at the upper level. If both the tanks are at the same level, water cannot pass from one tank to another tank. So when there is a difference in the level of water heights, water flow from one point to another point. In the same way, in a circuit, one point to another point, there is some difference of voltage is maintained. Okay. So that difference is called as potential difference or voltage. What is the unit? Volts. What is the formula? V is equal to W by Q. Work done by that charge. Okay. So it is measured by voltmeter connected in parallel. It is measured. How do we measure the electric potential difference? Voltmeter. That is voltage. Voltage is measured by voltmeter. So voltmeter, we have to connect it in parallel, not in series in the circuit. When you are drawing a circuit and when you are connecting a circuit to check the voltage, it should be connected in parallel connection, not series connection. So next one, Ohm's law. What is this Ohm's law? Ohm's law gives us the relation between, you can see the Ohm's law diagram triangle here. It gives the relation between voltage, current and R resistance. What is resistance? It is a property shown by a conductor. It opposes the flow of electrons. That is the resistance. So metals, they conduct electricity. They allow the electrons to pass through them. but still they have some resistance. They obstruct or object the flow, free flow of electrons. That nature is called as resistance. So, different metals will have different levels of resistance. Okay? So, here Ohm's law, it helps us to understand the relation between voltage, resistance and current. These three are interrelated. You can see voltage is equal to I into R, current into resistance. Resistance is equal to voltage by current. Current is equal to voltage by resistance. So, this is the relationship between voltage, current and resistance. Okay? So, this is all at constant temperature. If the temperature is constant, in that case, we can write it like this. Okay? V is equal to IR. Resistance is the opposition to current. Metals allow the current to pass through them, but still they have some opposition, some resistance. That is called as resistance. Okay? Ohm's law holds for many conductors. So, this relation, whatever the formulas here we have written, they are applied to ohmic conductors. Many conductors accept the Ohm's law, they fit to this Ohm's law. You can verify the Ohm's law, it will give you the correct result. Okay? But not all conductors. So, the conductors which obey the Ohm's law are called ohmic conductors. The conductors that do not obey the Ohm's law are called as non-ohmic conductors. Okay? Non-ohmic conductors. Right? This is about Ohm's law. Next, resistance. Just now we discussed about resistance. It is the property of the material that resists the flow of current. Okay? So, what are the factors that affect the resistance of a material? There are some factors which will increase or decrease the resistance. So, what are the factors? The resistance depends on length. It depends on length. Okay? Resistance directly proportional to length. That means, if the wire is too long, the resistance is more. If the length of the conductor is more, the resistance is more. Okay? Right? So, if you make the wiring short, the resistance is less heat is produced. Now, area of cross section, that means this is some wire. Okay? Right? So, this is the thickness of the wire, thickness of the conductor. You see this area of cross section. Here area of cross section is small. R is equal to, resistance is equal to inversely proportional 1 by A. That means what? That means what? So, in thin wire there is more resistance. In thick wire there is less resistance. Okay? If the wire is thick, the resistance is less. If the wire is thin, the resistance is more. If the electricity, same amount of current is passed through these conductors, which one there is more resistance? Here is more resistance. Here is less resistance. And third one is material. Okay? Material depends upon the material. So, depending upon the material, each material will have its own specific resistance. That is called as resistivity. Resistivity based on the material of that conductor. Okay? Specific. Okay? It is specific to that particular material. Next, temperature. So, how the temperature affects? Right? Temperature affects. More temperature, more resistance. More temperature, more resistance. So, resistivity R is equal to rho L by A. Its units ohm meters. Okay, next. Resistance of a system. Resistance of a system of resistors. System of resistors means, see, here is a wire. Here you kept one resistance or resistor. You kept one resistor. This is single resistor in a circuit, but you wanted to keep more resistors, 2 or 3. So, you can keep the resistors like this, here, 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 R1, R2, R3. So, this connection is series. You connected the resistors in series. You can connect the resistors in another way also. Resistor 1, resistor 2, R1, R2, R3. Now, these are connected like this. This is parallel connection. Okay? This is parallel connection, this is series connection. So, if you connect the resistors in series, what happens? The total resistance. So, what happened to the total resistance? R1 plus R2 plus R3. It is, okay, RS. Same current flows through each resistor. Same current flows through each resistor. Okay. The potential difference divides across the resistors. The potential difference divides across the resistors, but the same current flows. Resistors in parallel. If you make the connection in parallel, what happens? The total resistance is 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay. So, voltage across each resistor is same. The voltage between this resistor and this, okay, this point and this point is same. This point and this point is same. This point and this point is same. But here it is different. Here to here, here to here, here to here. Okay, in series. But in parallel, the voltage difference, whatever the voltage, the potential difference is same, is maintained same. Current divides in branches. Here voltage divides in branches, here current divides in branches. So that Rp is always less than the smallest resistor in case of resistors in parallel. Okay. So when the resistors are attached in series, here what divides here? Voltage divides, potential difference divides. But when they are attached in, when they are connected in parallel, this is parallel, then what divides? The current divides in branches, but the potential difference, that means the voltage remains same. Okay, that is the difference. Next, heating effect of electric current. Heating effect of electric current. When current flows through a conductor, because of resistance, some heat is produced. Okay, so the heat is produced. We are going to study about the heat produced in electricity. So for that we are studying Joule's law of heating. What does it states? Heat is equal to I square RT, current square into resistance into time. So how much time the current is passed, how much resistance that material has, and square of the current, that it gives the heat produced. This is Joule's law. So the heat produced is directly proportional to square of current, I square, current square. It is directly proportional to resistance. Okay, it is directly proportional to resistance. Resistance increases, heat increases. Directly proportional to time. If time increases, if you are passing the current for more time, more heat is produced. That is the Joule's law. That is the relation between heat and current, resistance and time. Heat is equal to current square into resistance into time. Okay. So what is the application of this heat? We are using heaters, hair dryer, hot air it releases, and induction stoves, electric kettles, iron to press our clothes, right? And water heaters, soldering rods, all these are the applications of heating effects of electricity. Electric heater, iron, geyser, toaster, these are all examples. Okay. So we can use this particular thing, that is that heat generated during electricity to make fuse. What is fuse? Fuse is an electrical component which prevent short circuit and overloading. Okay. See here, electric fuse melts when excessive current flows and it protects the appliances. So where is this electric fuse? Right. So electric fuse, the electric fuse will be like this. Okay. So here there will be a metal wire like this. So here we will give the connection here. Like this, not seen. So the current passes through the fuse, but here the fuse wire, when there is more temperature, it melts. If more current is passing through the fuse wire, the fuse wire it melts and it stops the supply of the power. So by that our gadgets are not spoiled because of high voltage, right? So that is the application of the heating effect of electric current. Next, electric power. What is this electric power? Rate of doing electric work is electric power, right? Rate of doing electrical work. So it is measured by P is equal to V into I, voltage into current. So by using the Ohm's law, we can write P is equal to IR into R, current square into resistance. P is equal to voltage square by resistance. Okay. So electric power is rate of doing electric work. At what rate the electric work is being done, if you calculate it, that is electric power. Why we should calculate? See, in our houses, meters are there, electric meters. So the electricity department, they would like to calculate how much electric power is used, because they would like to charge you how much you are using. So how do they charge? They cannot give the uniform payment for all the houses. They keep the meters, they see how many units of power you have spent, and that many units they will charge. So what is that unit? How do they calculate? By doing this calculation. So what is the SI unit of the electric power? Watts. 1 kilowatt, how many watts of current is used? 1 kilowatt is equal to 1000 watts. Okay, 1 kilowatt is equal to 1000 watts. For example, here is an appliance, here is a mixie or a grinder. Here you have a grinder. You have a grinder. So this grinder, its capacity is 1 kilowatt. If this grinder is run for 1 hour you are running it. 1 kilowatt per 1 hour. Okay. So 1 kilowatt appliance is running for 1 hour. It is called as 1 kilowatt hour. That means 1 unit is consumed. It takes 1 unit. Okay. If its capacity is 1 kilowatt per hour, that means in 1 hour it consumes 1 unit of electricity, right? Next, so the commercial unit of energy. The power companies use kilowatt hour. 1 kilowatt hour is equal to energy used when 1 kilowatt appliance runs for 1 hour. For example, there is a fridge. Its capacity is 1 kilowatt. That means in 1 hour it uses, okay, 1 kilowatt hour. It uses 1 kilowatt energy per 1 hour. That means 1 unit. It consumes 1 unit. So electricity bill is calculated based on the total units consumed. So in a month we will be consuming 500 units, 600 units, 300 units. So on basing that per unit they will put some charge, and on basing that they will do the calculation, right? So this is about the electricity and electric current, and that voltage, electric potential, potential difference, electric power. Hope you understood this lesson. This is a short summary, quick revision for this electricity lesson. I hope you like this lesson. If you have any doubts, please write them in the comment section. And if you like this video, please give it a like, and please subscribe to GradeBooster, and don't forget to share this video with your friends. Thank you.
Thanks for watching. Please like the video. Please share this video with your friends. Please subscribe to GradeBooster channel. Press the bell icon to get all the latest updates. Check the description to find links of other useful videos. Check the end screens for our new videos.